Hello everyone, welcome back to my channel. My name is Jason. Today we're going to continue the Kaggle Titanic survival prediction competition. This video is part 2 of a 2-part series, so if you haven't already watched the first one, I would highly recommend that you go watch that first and come back to this video. So in the previous video, we went over some exploratory data analysis to analyze the different features in our Titanic dataset, as well as explore how the different features affect the survival outcome of the passengers on the Titanic. Today we're going to focus more on the machine learning aspect of this competition, that is building a machine learning model and using that model to make predictions on the passenger data in the test set. So for today's video, we're going to look at the last two sections of this notebook, and they are data pre-processing as well as modeling. Beginning with data pre-processing. So data pre-processing is the process of getting our data set ready for model training. So in this section, we will perform the following pre-processing steps. So first, we're going to look at how we can drop and fill the missing values in our data set. And then we're going to move on to data transformation, or more specifically, log transformation. Next, we have feature engineering. And last but not least, we have feature encoding. We'll have a look at these steps in more detail as we go along. So starting with drop and fill missing values. What I've done here is actually drop the ticket as well as the cabin features from both the training set and the test set. But if you have the time, I highly encourage you to go through these two features in more detail and see if you can impute the missing values in both of these columns instead of dropping them entirely. And once I've dropped the ticket and cabin columns from the dataset, I went on to check the remaining missing values in the training set. So again, isNull.sum, sort the missing values going from highest to lowest. And so as you can see here, there are two remaining columns with missing values in the training set. The first one is age with 170 missing values, and the embark column has 2 missing values. So let's first work out what the mode is, or the most frequent value in the embark column. So as you can see here, the mode for the embark column is S. So S is the most frequent value in that column, and S is also one of the 3 locations a passenger on the Titanic can embark from. So what we're going to do now is just simply fill the missing values in the embark column via the fill_NA function with the mode value that we've just calculated. Now we're going to repeat the process of checking the remaining values in the test set. isNull.sum, .sort values ascending equals to false. So as you can see here, similar to the training set, test set also has some missing values in the age column and an additional missing value in the fare column. So how I'm going to address the missing value in the fare column is actually to fill it with the median. So again, we're going to calculate the median value for the fare column. And so as you can see here, the median is 14.4542. And then fill the missing value in the fare column with median that we've just calculated. And what I've done next is combine both the training set as well as the test set together via the concat function in pandas and assign that combined data frame to the variable called combine. And so these are the first 5 rows of our combined data frame. And then we're going to apply isNull.sum to our combined data frame and sort the missing values going from highest to lowest. So as you can see here in the output, the survive column has 418 missing values, and for age we have 256 missing values. We can ignore the missing values in the survive column because all of them are actually from the test set, because test set doesn't have a survive column. Now we just need to focus on filling the missing values in the age column. So the goal here is to use features that are most correlated with age and using those features to predict the missing values in the age column. But first we need to convert sex into numerical values where 0 represents male and 1 represents female. This process is known as encoding, and we'll explore this later on in the notebook. So what I've done here is convert sex into numerical values and assign 0 to male and 1 to female. Here I've used 3 separate factor plots to visualize the relationship between age, sex, Parch, and SIP. You can go through this plot in your own time. I've also used a heat map to visualize the relationship between the age column and the other numerical variables in our dataset. So what we're going to focus on is this age column in the middle. So as you can see here, sex has the lowest correlation with age, but age is negatively correlated with the other numerical features like SIP, SP, Parch, and P-class. And so what I've done here in this cell is to collect the indices of the missing values in the age column. And so next what this for loop does is it will loop through every single missing value in the age column and locate the rows that have the same values in the SIP, SP, Parch, and P-class column, and subsequently fill the missing age with the median of those rows. If no identical rows are found, simply fill the missing age with the median of the entire age column. And so what I've done here in this final cell is to make sure there's no more missing values in the age column. So as you can see here, after we apply the isNull.sum to the age column, we can see that we have 0 missing values. Now we're going to move on to data transformation. Recall from our previous video that our passenger fare column has a very high positive skewness, which means the distribution is visibly towards the left-hand side. Therefore, we will need to apply a log transformation to address this issue. So we're going to apply a log transformation via a lambda function. So a lambda is a convenient way for us to write a quick function in Python. And I've mapped that lambda function to our fare column. So this is the passenger fare distribution after applying the log transformation. As we can see here, our skewness has gone down dramatically from 4.51 down to 0.57. Now we're going to look at feature engineering. So feature engineering is arguably one of the most important arts in machine learning. It is simply the process of creating new features from existing features to better represent the underlying problem that we're trying to solve. So in this section, we're going to construct 3 new features, and their title, isAlone, and age times class. Bear in mind that these are not the only features that you can create. I've simply based this off of other people's notebooks, but feel free to come up with your own unique features and see if they help improve your model accuracy. So the first feature that we're going to construct is the title feature. Pay attention to the name column here. What we want is to extract the titles out of the name column. So we're going to first split the name where the comma is and take the second component of that split. So let's look at this with an example. After splitting the first row, we have this as our first part, followed by the second part. And we're going to split that string again where the full stop is and take the first part of that split. So this is our first part, followed by the full stop, followed by name. And we're going to do that for all the rows in the name column. And once we've collected all the titles, we're going to put it into a new column called title. And so this is the result of our feature engineering. So as you can see here, the title for the first row is Mr. For the second row is Mrs., Miss, Mrs., and Mr., and so on. This is a quick value count of the title column that we've just created. There are 18 unique titles in our new title column. And what I've done next is simplify the title further so that we have 5 remaining titles left. And the 5 remaining titles are Mr., Mrs., Miss, Master, and Rare. We're going to also compute the mean of survival by name title. So as you can see here, Mrs. has the highest mean of survival, Mr. has the lowest. Again, this demonstrates that female passengers were more likely to survive than male passengers. And then we're going to use a factor plot to visualize this result. So as you can see here, passengers that have the title Mrs. have the highest mean of survival. Passengers with the title Mr. have the lowest mean of survival. Now that we've successfully constructed our new title feature, we can safely drop the name column from our dataset. So now we're going to move on to our second new feature called isAlone. So here I've made a new column called family size. The way we're going to calculate family size is subsp plus paj plus 1. And so this is the output of our new column family size. So 1 plus 0 plus 1 is 2, 1 plus 0 plus 1 is 2, 0 plus 0 plus 1 is 1, and so on. Again, we're going to calculate the mean of survival by family size. As we can see here in the output, passengers with the family size of 4 have the highest mean of survival. And now we're going to move on to actually creating our isAlone feature. So passengers with a family size of 1 will receive the value 1 in the isAlone column. The remaining passengers will receive the value of 0 in the isAlone column. Now calculate the mean of survival by isAlone. So as you can see here from the output, passengers that were not alone on the Titanic were more likely to survive than passengers that were alone. And so after creating our isAlone column, we're going to go ahead and drop the subsp, paj, and family size column from our dataset. The last feature that we have in our feature engineering is age times class. We need to first transform age into an ordinal variable. So an ordinal variable is much like a categorical variable, but with an intrinsic ordering in their values. We will group ages into 5 separate age bands. So what I've done here is use the cut function in pandas and cut the age column into 5 separate age bands. And so these are the 5 separate age bands with their corresponding mean of survival. And so what I've done here is simply assign ordinals to each of the age bands that we've created, starting from 0 all the way down to 4. So the first age band will receive the value of 0, the second age band will receive the value of 1, and so on and so forth. And our final age band will receive the value of 4. And then what we're going to do is just go ahead and drop the age band column. And we're going to convert our age column, which is now an ordinal variable, to have the data type of an int. And now we can finally proceed to creating our age times class feature. By taking the age column and multiplying that with the p-class column, we have our new age times class feature. We're going to now move on to the very last step of our data preprocessing, which is feature encoding. So machine learning models require all input and output variables to be numeric. Therefore, we will need to encode all of our categorical variables before we can fit the models to our data. Just like how we've previously encoded the sex column by assigning the value of 0 to male and 1 to female, we're going to repeat this process for the remaining categorical variables in our data frame, such as title and embark. In addition, similar to the age column, I will also transform the fare into an ordinal variable. So we're going to now encode both the title and embark column in our data frame by using the getDummies function in pandas. So what getDummies has done is create 5 new columns for the title feature and 3 new columns for the embark feature, each representing a unique value in those columns. So for example, our first passenger embarked from location S and has the title Mr. So as we can observe from our new data frame, the first row has the value of 1 under the title Mr. column and a value of 1 under the embark_s column, with the remaining columns receiving a value of 0. So that is just one single row. We're going to repeat that process for all the rows in our data frame. And what I'm going to do next is divide the fare column into 4 separate bands using the cut function in pandas, and then assign ordinals to each of the fare band. Once we've done that, we want to convert the fare column into integer, and then we can now drop the fare band column. And so this is what our final data frame looks like. Now we can finally separate the training and test set from our combined data frame. So these are the first 5 rows of our training set, and I went ahead to drop the passenger ID column from the training set. Because the survive column is now a floating point number, I've converted it back to an int. And these are the first 5 rows of the test set, and we're going to go ahead and drop the survive column from the test set because survive is our target variable, and that's what we're going to predict once we've built our machine learning model. Alright, so now our data frames are ready for modeling. Alright, we finally reached the most exciting part of this competition, which is modeling. Scikit-learn is one of the most popular libraries for machine learning in Python, and that is what I've used for the modeling section of this project. I highly recommend checking out this scikit-learn documentation. I've included a link on my notebook, which will bring you to the scikit-learn website. There you'll find more information about the different machine learning models that is available as part of their library. So for this project specifically, I've chosen the following classifiers: logistic regression, support vector machines, k-nearest neighbors, Gaussian naive Bayes, perceptron, linear SVC, stochastic gradient descent, decision tree, random forest, and finally cat boost. So in this final section of the notebook, I'll feed these classifiers to the training set and evaluate the accuracy and making predictions. Once the best model has been determined, I will perform something called hyperparameter tuning to further boost the performance of that model. Now, before we get started with our modeling, we need to first split the training data up into independent variables represented by x, as well as dependent variable, or sometimes called a response variable, represented by y. Y-train is the survive column in our training set, and x-train is the other columns in the training set that is not survive. So when we apply the different models to our training set, our models will try to learn the relationship between x-train and y-train, and once our model has been built, we want to use that model to make predictions on x-tests. So here, let's have a look at the shape of x-train, y-train, as well as x-tests. So notice x-train and y-train have the same number of rows. X-train has 14 columns, whereas y-train is only a single column, which is our survive column. X-test is the independent variables in our test set. It has the same number of columns as our x-train. Modeling in scikit-learn requires 3 simple steps. First, we need to instantiate the model, which is declaring a model to a variable. Next, we want to fit the model to the training set. And once that model has been fitted, we want to use that model to predict the data in the test set. So starting with our first classifier, the logistic regression, we need to first instantiate the model. Here, I've declared the logistic regression model to the variable called logreg. Once we have established that variable, we're going to go ahead and fit the model to our training set, which includes both x-train as well as y-train. And finally, we're going to make predictions on the data in x-tests. And then we're just going to go ahead and calculate the training accuracy. So as you can see here, logistic regression has a training accuracy of 80.93. We're going to now repeat the process for the other classifiers. So support vector machines, k-nearest neighbors, Gaussian naive Bayes, perceptron, linear SVC, stochastic gradient descent, decision tree, random forest, and finally cat boost. Alright, once we've done that, the next step is to assess the performance of these models and select the one which has the highest prediction accuracy. So I've compiled the training accuracy from all the models into this data frame and sort them from highest to lowest. The top 3 models which have the highest training accuracy are random forest, decision tree, and cat boost. However, training accuracy does not tell the entire story. It is important that we don't get too carried away with models with impressive training accuracy, as what we are more interested in is the model's ability to predict out of sample data, or in other words, the data that our model has not been trained on. So this is where k-fold cross-validation comes in. K-fold cross-validation is a technique whereby a subset of our training set is kept aside. So our model is not going to see that portion of our training set. We're going to reserve that training set for testing purposes. I won't go through in too much detail the process behind k-fold cross-validation, but I have included a link here on my notebook which will bring you to a video which does an excellent job at explaining what k-fold cross-validation is. So what I've done here is create a list called classifiers, which contains the 10 classifiers that we're going to use. And then we're going to use a for loop to loop through each classifier and perform a 10-fold cross-validation. Following that, we're going to calculate the mean as well as the standard deviation of the cross-validation results. And finally put them in a data frame that looks something like this. So I have sorted the values of the cross-validation mean from the highest to lowest. So as you can see here, support vector machines is our best performing model. This is just a bar plot of the ranking of our classifiers. So again, support vector machines is our best performing model. Alright, so now that we've chosen support vector machines as our model of choice, we're going to now perform hyperparameter tuning, which is the process of tuning the parameters of a model. Here, I will tune the parameters of our support vector classifier using a function called grid_search_cv, which is again part of the scikit-learn library. So after completing that process, we have found the best parameters for our support vector classifier. So what we're going to do now is use those parameters in our support vector classifier, fit the classifier to our training set, and finally make predictions on our test set. So after calculating the average cross-validation score using our new support vector classifier, we can see that our score improved slightly. Here, I've stored the predictions made by our model to a variable called ypred. And if we have a look at what ypred looks like, it is a list that contains values 0 and 1. So these are essentially the survival predictions on the data in the test set. And as you can see here, ypred has 418 elements in the list, which is the same number of rows in the test set. Alright, so now that our predictions are ready, we can prepare our data frame for submission. So these are the first 5 rows of the sample submission, which is one of the datasets that were provided as part of this competition. So there are 418 rows and 2 columns, and those 2 columns are passenger ID, as well as the survive column. So now what we want to do is create a data frame using pandas. In the passenger ID column, we want the passenger ID in the test set, and in the survive column, we want to put in our predictions that have been made by our model. And just to make sure our submission data frame has the same shape as our sample submission, so everything checks out, we have 418 rows and 2 columns. Now our data frame is finally ready for submission. Before I wrap this video up, I just want to quickly go through some possible extensions that you can use that will potentially improve your model accuracy. First is to analyze the ticket and cabin features. Recall that early on I've dropped both of these columns from the data frame. But if you have the time, I highly encourage you to go through both of these features in more detail and consider imputing the missing values in those columns and use those 2 columns as part of your training set and see if it makes any difference to your model accuracy. Secondly, you can also come up with alternative features in feature engineering. Thirdly, we have remove features that are less important. This removing features help reduce overfitting in our model. Last but not least, we have ensemble modeling. This is a more advanced machine learning technique whereby you combine prediction results from multiple machine learning models. Ensemble learning has consistently helped many people achieve a far superior prediction results than using just a single model. So to wrap up this video, I have achieved a submission score of 77.5%, or in other words, I've correctly predicted 77.5% of the data in the test set. I highly encourage those of you, especially who are beginners, to work through this project again and see if you can improve upon my prediction results. If you found any mistakes in your notebook or places you think I could potentially improve on, feel free to reach out to me. As usual, if you enjoyed this video, please drop a like, subscribe to my channel. You'll greatly help the channel grow as well as motivate me to put out more content. Take care, keep learning, and I look forward to seeing you in my next video.